Everyone, thank you so much for being here. So far today, we've seen some awesome sessions on topics like purple teaming, error simulation, threat intelligence, and more. With this talk, I'd like to pivot just a little bit and instead talk about cloud pen testing, specifically on AWS. In a lot of ways, AWS has become sort of the default go-to cloud service provider, hosting an unimaginable number of applications and workloads for an equally unimaginable number of customers. For penetration testers, AWS environments are a bit different compared to the traditional on-prem infrastructure that we're likely used to. But they can also offer us an additional layer of attack surface that we can take advantage of to compromise those cloud environments. The question is, what is that attack surface and how do we make the most of it? So in this talk, I'd like to share a number of things that I wish I knew before I got involved in AWS pen testing. Some of the techniques, misconfigurations to look out for, and general information to help you succeed on your next AWS pen test. Before we get started, you're probably wondering, who am I and why do I want to tell you so much about AWS? Hi, my name is Nick Frichette. I'm a senior security researcher over at Datadog, where I work on our cloud security products. I've been involved in offensive security in some form or the other for the past 4 or 5 years. In a previous role, I was the team lead for the penetration testing team over at State Farm Insurance. In my free time, I'm the creator and primary maintainer of Hacking the Cloud, which is an open source encyclopedia of offensive security techniques that you can use in cloud environments. Before we get started, 2 disclaimers. The first is that I had a lot of content for this talk, but not a lot of time. So things that didn't quite make the cut, as well as additional resources, links, information, and more can be found in the slide notes, which you can pick up at that URL, or if you prefer QR codes, that QR code. Additionally, with this talk, I wanted to try to avoid some of the more common talking points around AWS pen testing. Things like server-side request forgery from the EC2 metadata service to steal IAM creds, or enumerating IAM users or roles across account. That way, whether you've been doing this for years and have a ton of experience and hence know all that stuff, or if you're completely brand new to the topic, I hope you can come away with this talk with something that's totally new to you. And with all that out of the way, let's get started. So a major topic when it comes to AWS pen testing is attacks against IAM, identity and access management. The sort of textbook scenario that often plays out is something like compromising an internet-facing web application, either getting remote code execution or perhaps via server-side request forgery. You then pull IAM credentials off that host that you can use to access the AWS API. And from there, that leads to all sorts of fun activities like privilege escalation, lateral movement, accessing resources that the owners probably don't want you to access, and stuff like that. Now, in these situations, what we're actually abusing, what we're actually taking advantage of, are what we would refer to as identity-based policies. These are policies that are attached to some entity, whether that be a user or role or group, in this situation, one that we have compromised. And those policies are a collection of statements that define the permissions of that entity, what that entity is permitted to do. In order to do basically anything in AWS, you need to have the identity policy that permits it. So if you wanted to, say, perform that super cool privilege escalation, you need to have the identity policy that would permit it. What's interesting, though, is there is a bit of an exception to this. While this applies to most situations, there's actually one sort of cutout in which we can get around that. And that is in the form of resource-based policies. Resource-based policies are a bit of an inverse of an identity policy. Rather than being attached to an entity, a resource-based policy is attached to some AWS resource, such as an S3 bucket. And that policy includes a bunch of statements that define what actions other entities can perform on it. And so if you've never seen one before, it looks something like this. And there's a couple key elements within the policy that affect its security and what you can do to it. So just going through the key ones, that effect is a simple allow or deny. Either the statement permits an action or it denies it. The principle is the who of the policy. Who is permitted to perform or not perform a particular action. And there's actually a pretty wide array of different options for what you can put within a principal. It can be very fine-grained, down to an individual role or user, or it could be more broad, open to entire AWS accounts at a time. It can also include something that's called the wildcard principle, which we'll talk about in just a little bit. The principal element within a policy typically is what you can take advantage of. If it's scoped too broadly, you may find yourself in a position to be able to access that resource and abuse it in some way. Or even if it is perfectly well written, scoped down to a specific user or role, sometimes if you just compromise that user or role, now you have a potential access to that resource. The next element that's worth mentioning is the action. This is the actual AWS API call that is either permitted or denied by the policy. And this is sort of the second most common thing that can be abused in a resource policy. If, again, that action is too broad, scoped too widely, you may have an opportunity to abuse that resource in some way. And we'll see a real-world example of that in just a little bit. And finally, we have the resource, the thing the policy is attached to. If we were to take all of that and actually read this policy, what it would say is that this policy allows the user tester to perform the action S3 list bucket on the resource superfun bucket. Now, I mentioned that resource policies kind of get around the traditional identity authentication process, or excuse me, authorization process in IAM. And the reason for this is within the same account, taking this policy as an example of the tester user, even though this user has no permissions at all, they are still able to perform an action on a resource. As seen by this screenshot, that tester user is still permitted to perform S3 list bucket, or LS, on the superfun bucket. So this is especially important for penetration testers or red teamers, as oftentimes when we compromise some identity in an environment, we're very focused on their identity policies and what they're permitted to do. But we have to be mindful that there can also be a number of resources in that environment which may have a pre-existing trust relationship, an explicit trust relationship back to that resource. And those can potentially be things that we can take advantage of or abuse. Another interesting thing to note about resource policies, to be clear, they can be misconfigured a number of different ways depending on the situation and what you have access to at any given time. The one principle, though, that is sort of the easiest to go wrong is what we refer to as the wildcard principle, sometimes referred to as the star principle. Now, the star principle or the wildcard principle encompasses all AWS principles, not just those in the same account and not just those in the same AWS organization. It's everybody. And so in this situation, if we were to read this policy, what it would say is that this policy allows everyone the ability to perform the action S3 get object or download an S3 object on the resource super public fun bucket. Now, I know what you're thinking, Nick, there's no way that anybody would set a policy this broad and leak the entire contents of an S3 bucket to everyone in the world, potentially exposing sensitive data and potentially millions of customer records. And based on the giggles I heard, I'm assuming most folks know that I'm joking. Unfortunately, this happens a lot. It's almost a meme at this point within the cloud security community, the idea of the leaky S3 bucket that leaks some millions of records or some terabytes of data. And this is sort of a wide-reaching issue, and not even just specific to AWS. Just a couple of weeks ago, Microsoft had an incident with their own equivalent to S3, that being blob storage in Azure, where they were leaking a bunch of information for, if I recall correctly, something related to like vendor relations. So it is a very common and sort of thing you'll see quite a bit. And it's definitely something that we should be mindful as penetration testers. Now, you're probably thinking, Nick, I thought you wanted to stay away from the common stuff. Why are you mentioning like the issue? There's two additional takeaways that I'd really want to stress about resource-based policies. And the first is that I think there's actually potentially a worst case situation than just leaking a bunch of data on S3. And to demonstrate this, I'd like to give you a very real world example of something that happened back in 2020 to a pretty well-known telecommunications company. See, they were using a public S3 bucket to distribute their JavaScript SDK. And the bucket policy, which is a form of resource-based policy, looked like this. Now, to be fair, public S3 bucket, totally valid use case for distributing a JavaScript SDK. If you want everybody in the world to access something, public object makes a ton of sense. Unfortunately, due to a misconfiguration, due to a mistake, the policy was too broad. It was insecure. If you'll notice in the action, they provided the permission to get object, so allowing anybody the ability to download the contents of the bucket. But they also permitted put object, which would permit anybody to upload to that bucket. And so what that meant was that an attacker was able to download that SDK, backdoor it, insert malicious code into it, and then push that back into that S3 bucket. And for consumers of that code, whether that be developers or perhaps as a part of a CI/CD pipeline, that's the real bucket. Like it's the right domain, it's the right resource. From the outside looking in, it looks 100% legit, but unfortunately, due to this mistake and this misconfiguration, that resource had been compromised. And so when you pulled it down, you're now running malicious code. And if I recall correctly, this was related to some of the mage card attacks that were in vogue at the time. But the key takeaway here is that while oftentimes when we think about resource-based policies, we're very focused on, again, the meme of read all the stuff out of S3, but we have to be mindful that we may be able to write as well, and that may have its own security impacts. The second major takeaway that I'd like to express is that when I talk to a lot of cloud security folks and I mention resource policies, they're very quick to say, oh, Nick, don't worry, we've got the block public access on, S3 buckets are locked down, it's not an issue, we're good. And that's great. But unfortunately, resource policies apply to a large amount of resources, not just S3. And any one of them can be compromised or taken advantage of depending on misconfigurations in those policies. So for example, in containerized environments, something like Amazon ECR, Elastic Container Registry, which if you're not familiar is just a Docker container storage solution. Amazon ECR uses resource policies to determine who is permitted to download containers as well as who is permitted to upload containers. And so you may find yourself in a position to be able to download the contents of a Docker container, which may contain source code, potentially credentials, although I hope not, as well as maybe other information that might be useful to you as an attacker. Or you might be in a position to upload a container inside an Elastic Container Registry, which then when some consumer comes along to run that container, whether that be ECS, EKS, EC2, Lambda, what have you, when that container executes, that's your code running in that environment. And from there, you can do things like trying to steal credentials from the metadata service, moving laterally across the network, trying to hit different things from, hit endpoints from a different perspective, and more. Another example, and I see my arrows did not translate well to PowerPoint. In serverless environments, the big problem with serverless from an attacker's perspective is often that the attack surface is so small. Typically, you have to go for more like application security focused attacks, which to be fair are 100% valid, but you lose a lot of the opportunity that you would get with traditional applications as an attacker. But resource policies can be an additional layer that we can take advantage of and potentially abuse to compromise those applications. So to oversimplify quite a bit, a lot of serverless environments end up looking like a bunch of Lambda functions strung together with SQS queues and SNS topics. And so as an attacker, if those policies are misconfigured, you may find yourself in a position to be able to pull messages from those queues, which may contain sensitive information, or you may be able to write to those queues, which may trigger additional functionality deeper within the application that may be advantageous to you. Another example is IEM. IEM uses its own version of resource-based policies in the form of the role trust policy, which is who is permitted to assume a role. As absolutely terrifying as it sounds, you can create a role that can be assumed by anyone in the world with a wildcard principle. And additionally, even if it's not that broad, you may find yourself in a position to try and assume a role either cross account that may be more privileged or of more value to you. If you are looking to do, if you're doing sort of like a white box, full knowledge type assessment where you may have, say, a read-only role in the account, or perhaps like the security audit role, and you're sort of assessing for common security issues. Personally, I've had a lot of luck with Prowler. Prowler is an open source tool that, for lack of a better term, runs a bunch of cloud security checks in the account. And it does a very good job at finding misconfigured resource policies. And of course, there are other options. The one thing I will caution you on, though, if you are using automation to do this, and this applies to everything, not just Prowler, in the event that there is a condition attached to a resource policy, most automation kind of bails out or gives up. And a condition is an optional policy element that does what the name implies. There's a condition under which something can be allowed or can be rejected. The problem with conditions from an automation perspective is that the condition language is very, very, very diverse. You can put all kinds of different conditions on there, and different resources adhere to different condition keys, if that makes any sense. Some are available for some services, some are not. And so for most automation, if it sees that there is a condition, it just kind of goes, I don't know, it might be vulnerable, it might not be, it kind of gives up. So if you are using automation to scan for these, just be aware of that while the most egregious ones may be caught, there may be some more complex issues that potentially could be vulnerable. It just requires a human eye. Now, all that being said, this might also work to your advantage as a pen tester. In the same way that it's difficult for you to run automation to find all these, it's also difficult for DevOps teams and security teams to do that as well. And so you coming in as sort of the human element, evaluating these policies, you might have an opportunity to find misconfigurations or things that you can abuse and potentially take advantage of them. Next, I'd like to talk just a little bit about multi-account architecture. So in AWS, for most mid to large size environments that you would be going up against, most of them will be using multiple AWS accounts. And there's a lot of benefit to doing this, both from a security perspective as well as an operational perspective. That being said, there are some challenges. For every AWS account that you add, that's more overhead in the form of ensuring logs go to the right place, determining ownership, making sure that you have everything correctly delineated between testing, staging, prod, pre-prod, and all that jazz. It could certainly be a challenge, particularly as you get into the tens or maybe even hundreds of AWS accounts. Now, to solve that problem, AWS created a service called AWS Organizations, which more or less helps you manage all of your AWS accounts, set them up to log appropriately, and configure them, set up ways to monitor that they are in the right environment. For penetration testers and red teamers, AWS Organizations is an incredibly important service to learn about because its default configuration can leave you in a position to be able to compromise every AWS account that a company owns. The first thing we should mention when it comes to AWS Organizations, that the account that creates the organization becomes the management account. Every organization will have one management account, and that account effectively owns the organization. From that, via Organizations, every time you create a new account, those accounts are considered member accounts. Hence, they are a member of the organization. Now, by default, AWS Organizations creates a role in each of the member accounts called the Organization Account Access role. And this role is incredible from an attacker's perspective because by default, out of the box, batteries included, that role has administrator access to those member accounts. So complete access to everything in it. And by default, the role trust policy, which is a form of resource-based policy, by default, the trust policy is just set to the management account. And so what this means is that if you can compromise that management account and through some means get access to assume role privileges, you now have a direct path by default to compromise every account in that organization as an administrator. And so obviously for penetration testers and red teamers, that management account becomes an incredible target because if you succeed in compromising it, the payoff is enormous. And so as penetration testers, we have to ask ourselves a number of questions about that account. For instance, what's running in that account? Is there any infrastructure that's been deployed to it that I could potentially take advantage of or exploit to gain a shell or hit the metadata service to steal IEM creds, and from there either privest or perhaps just pivot off that to more? Is there any existing role trust relationship between some of those member accounts and that management account? You get into sort of these like bloodhound-esque attack path graphs where you're trying to figure out, if I pivot between accounts, do I eventually hit that management account? And from there, take over everything. Are there IEM creds sitting on developer workstations, in source control, in scripts somewhere, in a network share, anywhere possible that I can steal that might get me access to that management account? CI/CD and IAC is its own conversation. Most mature organizations will have a CI/CD pipeline or an infrastructure as code pipeline, and those lead to attacks such as, if you phish a developer, if you steal their creds, if you get code execution on the box, if you find automation creds somewhere, can you use those to try and affect the CI/CD pipeline? What stops a developer on team A from being able to deploy into team B's infrastructure, and can you instead target the management account? And CI/CD infrastructure itself tends to lend itself very well to attacks. So for example, if it's just running your code, where is that code running? Is that running in somewhere important that you might be able to either pivot off of or abuse? Additionally, at the end of the day, that infrastructure has to have the privilege to do those deployments. So if you compromise it, can you steal that level of privilege? Single sign-on. Azure AD, Okta, G Suite, AWS Identity Center, all of these may be potential pathways that you can abuse or take advantage of to get into that management account. And so again, for attackers and penetration testers, the management AWS account by default becomes an immense target. If you are on an internal pen test team, I'd encourage you to poke around your organization to see what potential pathways might be there for you to potentially compromise. Next, similar idea, but not like strictly associated with AWS organizations. I did want to mention, in a lot of companies, there are a handful of business units and teams that have like a legitimate reason to be able to pivot to other accounts in the organization. So for example, security teams may need a role in each account in order to do things like triage and incident response. And those roles may have a pre-existing trust relationship back to some centralized security account. Or you may have platform engineering teams who similarly have a need to be able to help troubleshoot their customers, quote unquote. And those roles may too have a trust relationship back to that platform engineering account. So as penetration testers, we want to be mindful about core critical accounts that may exist in an organization that may be excellent passive attack to gain compromise over a lot of that infrastructure. Next, I'm sure many cloud hackers are familiar with that IP address. This is the EC2 metadata service IP address. You hit it and you steal creds, you service a request forgery, it's all great, it's a fun time. I actually want to talk about a slightly different endpoint. Same IP address, but instead of /latest/metadata, let's talk about /latest/user data. So user data can be incredibly valuable to an attacker, particularly if you're doing more like black box, adversary emulation, no knowledge type assessment. User data is a script that is run either the first time an EC2 instance is started, or with some configuration, every time an EC2 instance is rebooted. And typically what this is used for is things like installing software, downloading agents to the host, downloading configuration files, starting application servers, connecting to databases, and more. And for an attacker, this can be incredibly valuable information, not just about the host, but about the wider AWS account as a whole. So for instance, if you were to hypothetically shell some EC2 instance and do complete black box, you know nothing about the account, well, you're kind of in the dark. But if you get the user data, you might find out more information about that account and what resources you may have access to. So for example, you may find things such as credentials that are stored in some sort of credential vaulting solution, something like AWS Secrets Manager, or perhaps external things as well, like HashiCorp Vault. You may find out about RDS databases that you may be able to connect to, or S3 buckets that you may be able to pull information from. User data can be incredibly useful in that sense. Additionally, I mentioned credentials stored in Secrets Manager and credential vaulting solutions. Developers' favorite thing, aside from storing it there, is also just hard coding the passwords into the user data, which is really bad from a security perspective. One thing I really appreciate is in the AWS documentation for user data, they have this lovely red box with the big exclamation point and the importance sign, where they very explicitly warn you that like, hey, quote, you should not store sensitive data such as passwords or long-lived encryption keys as user data. So it's a prevalent issue to run into. And if you were to land on a host and look at user data, there's probably a good likelihood you may find plain text credentials, which might be super valuable. Now, as much as I love this big red box, unfortunately, it does have a flaw. This first sentence, in particular, the quote, you can only access instance metadata and user data from within the instance itself, is strictly speaking not true. You can access user data completely remotely via the API. And so if you find yourself in a position to be able to call either EC2 describe instance attribute, you can pull that user data just fine, which again, might have credentials in it, which is not great, and that might be very useful to you. Additionally, if you are doing sort of the full knowledge white box assessment where you have that read-only role, you can pull all these user data scripts remotely via the API. And that way, even if you don't shell the box, you can still review those for security issues that might pop up as a part of maybe installing software, configuring things, or there's just plain text credentials stored in them. And that could be very helpful to try and provide a more effective assessment for the customer. You don't necessarily have to shell everything. You just review the user data scripts and point out any sort of issues there. Additionally, user data also lends itself very well as a privilege escalation vector. I mentioned it's a script that's run the first time an EC2 instance is started or with some configuration every time it reboots. It runs as root, which is great. And so that could be an excellent privilege escalation vector. Couple different ways it can go down, the most boring of which is just you stop the instance, you change it, and you bring it back up, and now you have root. The more likely one, the more that sort of like least privileged version of this, a sort of common design pattern for user data scripts is that developers will have some sort of core functionality in an external script, and then as part of user data, you just download that script and execute it. The reason for that is that if you ever have to update it, it's not like you go down to your 1,000 or tens of thousands of EC2 instances. You just update that thing in S3, and then all subsequent invocations are updated now. The problem, as we saw with the real world example, is sometimes when developers want to provide read access to something, they also provide write access. And you may be in a situation where you could pull down that script, backdoor it, and then push it back into that S3 bucket. And then all subsequent invocations now will have you running code as root on those hosts. This is especially relevant for auto-scaling groups, which is a service managed by AWS where, for lack of a better term, if you get more traffic, AWS will spin up more EC2 instances. If you get less traffic, it spins up fewer. So every time a new EC2 instance spins up, pulls down the user data, it runs, you have code execution as root. And so this could be an excellent vector for privilege escalation as well as persistence. You will have a way to get back to a host that may have an IAM role that might be advantageous to you. Next, I wanted to talk a little bit about one of the more common security, I guess you call it a scenario. So the sort of storied way that a lot of AWS attacks go down is you abuse some web-facing web application and you steal IAM credentials either via SSRF or RCE. You have those creds. The problem is if you steal those creds off an EC2 instance and try to use them from your local machine, you're going to get caught immediately. And that's because of this thing called GuardDuty. GuardDuty is a managed threat detection service offered by AWS that has a bunch of detection rules for common security situations that might occur in AWS. It's all things considered relatively cheap, it's cost effective, and as a result, it's considered a best practice to run it. If you're going up against an AWS environment, they're almost assuredly using GuardDuty. And like I said, it has a bunch of threat detection rules, one of which is if it sees that you stole creds off an EC2 instance and used them somewhere else, it gets really unhappy, it alerts the SOC, they come find you, you have a bad day. Some folks might remember that back in the day, there was a way around this. What you could do, as silly as it sounds, is you could spin up your own EC2 instance and then use your stolen credentials from there. And all GuardDuty was doing was seeing, does this source IP belong to EC2? If it does, that's totally fine. And so that was the way around it. Unfortunately, or fortunately, depending on your perspective on the red-blue side, AWS closed this loophole earlier this year. And they did that by renaming the existing rule to outside AWS. So if you use them from your home connection or anything that doesn't belong to Amazon, it gets really unhappy. It alerts the SOC, they come find you, you have a bad day. But they also created an inside AWS rule as well. So if you try to use EC2 creds on a different EC2 instance, it sees that, it alerts the SOC, they come find you, you have a bad day. And so this is really unfortunate, especially considering that this is like the go-to cloud pen testing technique of, hey, I'm going to server-side request forwardry that thing, steal creds, and now I have access to IAM. The good news, though, is we can totally bypass all of this thanks to this thing called VPC endpoints. A VPC endpoint is designed to solve a problem that Amazon had with highly secure infrastructure. If you do everything right and you build these incredibly secure environments that don't have outbound internet access, the problem becomes you can't spend more money on AWS because you can't reach AWS endpoints. You can't make use of things like S3 or any of the other useful AWS APIs. So the solution was the VPC endpoint. A VPC endpoint is an endpoint that you can put within your private subnet, within your VPC, and then your EC2 instances can talk to that VPC endpoint to access the API and all the useful services. Now, the neat thing about VPC endpoints is that A, they don't go out via the public internet, so that outside AWS thing is completely not an issue. But B, I don't think we have a specific reason as to why this occurs. We don't, at least from the outside, I'm sure some folks inside AWS could tell us. But as far as we can tell, no matter what API call you make, as long as you route it through a VPC endpoint, it does not trigger the inside AWS GuardDuty alert. And so this can be a way that we can use stolen IAM credentials from an EC2 instance without getting caught. Now, the unfortunate thing about all this is that, for lack of a better term, it's a huge pain to set up because you have to create the VPC, you have to create the private subnet, you have to block outbound internet access so you don't risk leaking anything. You have to create the EC2 instance and then all the VPC endpoints, ensure that DNS is going to the right place. It's certainly a hassle, and as someone who has done this manually a couple times, it's not optimal. The good news is through the power of IAC, I created a bunch of scripts for you, so it can be as easy as git clone, Terraform init, Terraform apply. Within 5 to 7 minutes, you'll have a fully set up, isolated environment where you can use those stolen IAM credentials without having to worry about getting caught. And that's it. Thank you all so much for being here. If you have any questions, I'll be around today and tomorrow, or feel free to follow me on Twitter or Mastodon. Thank you.